Hello again. Today we're going to have a look at how the Q-learning algorithm does against our maze. So, quick reminder, here's what our base maze looks like. And for this algorithm, for our rows, I selected every possible position of the agent in the maze, so every possible coordinate, so the white coordinates. And for our columns or actions, that is simply every possible action: up, down, left, right, and stay. And the initial reward matrix started by awarding 100 points for staying at the exit, and then we propagate from there. So looking at the different iterations of the algorithm. So to clarify what I mean by an iteration of the algorithm, each iteration looks at every possible position and possible moves from that position, so possible actions, and updates once. So a single update across the board, that counts as an iteration, and the second iteration does the same thing to the resultant answer, so that is 2 updates across the board, and so forth with the third and fourth, and on and on. So looking at the agents resulting from each iteration, we see that they are essentially the same, and that was quite disappointing, but this is actually a result of the backpropagation. So since our initial reward matrix rewards us 0 for everything else and 100 for staying at the exit if you are at the exit, the propagation of information or backpropagation starts at the end. So when we do a run with one of our agents, unfortunately they start at the beginning and there's not that much information about the beginning. So that's what's being illustrated here with the agent moving back and forth in the beginning of the matrix, the maze, and essentially moving randomly. And on the side here is the percentage of changed rows on the Q table against the number of runs. So that is the number of rows that have changed from being all 0. So the amount of information we've gained, essentially. And we see, even though that we're gaining information, the motion of our agent is not really improving. It remains pretty random. But if one runs enough iterations, that is about 200 iterations, and we have a look at the solution, we see that the agent just follows the solution path of the maze, just like that. So the algorithm does work. Taking into account the backpropagation, I created this visualization which highlights those squares in the maze for which we've learnt something. So squares in the maze for which the corresponding row on the Q table is non-zero. So as the Q table updates, the visualization would then change that row from being a gray row, which is a row with all reward values for all moves being 0 to a white row, which is a row or a position which we've learned something about. So the payoffs for all actions are not 0. And as we can see, as I mentioned with the backpropagation, learning starts from the end and spreads out from there. And that is why if we have very few iterations or updates of the table, we don't see much of a difference, but for large enough iterations, we get the correct solution to the maze. So like before, we also made modifications to the maze. So these are the same as the ones done for the last video, the video on the dead-end algorithm and the split agent algorithm. So just to see how the algorithm handles these modifications, and looking at that for our first modification with the block and loop as well as alternative path, we see that Q-learning manages to take the shorter alternative route. And if we look at the visualization of the backpropagation, that is also pretty nice, spreading out from the end all the way to the start. And the loops and block don't seem to pose a problem for this. Okay, then moving on to our second modification of the maze. So that is adding some more alternative paths and loops. We have that the Q-learning agent still takes the alternative path. So we're taking the shortest route, and again, looking at the backpropagation, it's still looking pretty nice. The agent finding no issue with any of the loops or the block. So closing comment, this algorithm did pretty well. Didn't struggle with any of the loops or alternative paths, especially didn't struggle with the block, whereas the split agent algorithm struggled there. So I'd say it's at least on par with the dead end elimination. One does need to just be cognizant of the fact that your agent is trying to move through the maze from the start to the exit, whereas the Q-learning algorithm actually gains more information in the opposite direction, so from the exit to the start. So yes, that is why after running the algorithm for quite a while, it might look like the agent you produce doesn't learn much. But other than that, I would say the results were pretty satisfactory. And yeah, thank you. Till next time.